Create obstacle geometry for motor mounts. In this video, we'll create a sketch, we'll use the Edit Model workspace, we'll use Extrude, and we'll use Connector Obstacle. In Fusion 360, we want to carry on with our generative design geometry setup. We've already selected some preserved geometry that was contained inside of this design, but now we want to create some of our own. We're going to get started by taking a look at creating some obstacle geometry using Edit Model. Edit Model allows us to create geometry that is only included in our generative design studies. This means anything that we do in terms of modifying, editing, removing, or even adding geometry to our design doesn't go back to the design workspace. This can be extremely helpful because we can explore different design ideas without having to affect the original design. What we're going to do is we're going to explore creating some obstacles for our motor mounts. In order to do this, we want to explore a couple different ways that we can produce this geometry. First, from the Create menu, we can simply create a new sketch. To do this, let's select Create Sketch, and let's take a look at our shock. We're going to select the outside face of the shock, and then we're going to use some of our standard tools, such as center diameter circle, and in this case, I'm going to draw a 55mm diameter. Remember that when we start a new sketch on a face, it's going to automatically bring in that 50mm outside diameter as well as the inside diameter. So from here, I'm going to finish the sketch. I'm going to select Create Extrude, and I'm going to begin by extruding the larger diameter as well as the center portion out and away. I'm going to bring this out a distance of 35mm, and I want to create a new body. Then I need to go back into my model components, into my sketches, and the sketch I just created. I want to extrude once more, and this time I'm going to grab the center, and I'm going to bring this all the way into the middle. You might need to go to a front view, but note that at 50mm, we're right in the center. From here, if we select Join, it's going to join it to all the solid bodies. So we're going to select New Body, and we'll use Combine to join it together. Let's rotate this slightly and hide our sketch. Next, I'm going to use Create and select Mirror. I'm going to mirror specific bodies, including this outside one that we just created, and we'll need to expand our Bodies folder and select Body 27. The mirror plane is going to be our standard plane, and it can be problematic to find this with all the other geometry. It's going to be in the rear wheel, and we want to select the mirror plane as YZ. Note that the operation is set to join, and if we say OK, the result is 3 bodies. We get this warning because we had 2 initial bodies that we mirrored and it wasn't able to join them all together. But we can use Modify and Combine to join body 28, 27, and 26 together. So the target bodies and the tool bodies don't really matter in this instance, but we want to make sure that we join those 3 together. And now we have created our first obstacle. That process took a little bit of time and it was pretty cumbersome for us to do. There are better ways that we can do this using some of the tools that we have at our disposal, such as Connector Obstacle. When we use Connector Obstacle, we begin by selecting the start of the shaft. In this case, the shaft is going the wrong direction, so I'm simply going to bring it inward. In this case, I want to make sure that I go at least 60mm, and I want to extend past the boss we're going to be using to mount to our frame. We're going to use bolt head, and we're also going to use tool clearance. For the bolt head diameter, we're going to set this diameter at 20mm. Then for our tool clearance, we're going to set the diameter at 30mm, and we're going to set it to a distance of 50mm. We're going to say OK, and now we've created a new obstacle using that tool that was much quicker than creating our sketch and manually creating those entities. Let's repeat that process by using our right-click marking menu and going to the 12 o'clock position. Once again, we'll select the start and we'll drag that in a distance of 60mm. We'll use bolt head and tool clearance. Once again, we want to modify these values. The head diameter of 20mm. We'll set the tool diameter at 50mm on the front, and we're going to set it to a distance of 50. This tool is not going to remember our previous settings, and you can see that we have different values for the front and back. What's important to note is what we're really doing here is we're defining the head of the bolt and how much clearance we actually need to get to it. Keeping in mind that in most cases, if we are going to have a hex bolt, for example, then we would need to make sure that the diameter of the head clearance is large enough to accommodate the tool that we're using. In this case, we're going to be using an Allen key or some sort of Torx, so we don't really need to get all the way around the bolt head. But keep in mind that it is important for us to remember that there are specific instances where we might need to increase these values. Let's repeat the process on the other side, noting that the orientation of this in relationship to our coordinate system means that we don't need to really make any adjustments. I'm just going to increase the length to 60 millimeters. I'm going to add my bolt head at 20 millimeters, and then I want to add the tool clearance. Once again, the tool diameter in this case, I'm going to leave at 35 millimeters on the backside, and I'm going to let it go 50 millimeters. We'll repeat this one more time. Once again, increasing this to 60 millimeters, adding our bolt head and our tool clearance. Once again, using those same values, I'm going to have the tool diameter equal to 50 on the front, and I'm going to have it extend 50 as well. You might be wondering why the tool clearance is different on the front. Well, in general, when you have a motorcycle, you might include other things such as frame sliders that would bolt to the frame. Increasing the tool clearance on the front is really more of a design aspect rather than getting the tool into that area. It just means that we have enough room for adding additional functionality downstream. There are more items that we need to create as obstacles, but for now let's finish Edit Model and let's take a look at what we have already defined as an obstacle and what has not been created as an obstacle. Anything that we did with our connector obstacle tool is automatically defined as an obstacle. However, the ones we used with our sketch, extrude, and mirror are simply just other bodies in the design. So we need to go to obstacle geometry and we need to add that element and say OK. So that's another benefit of using the connector obstacle is it easily and quickly makes those connector obstacles for us, but it also pre-selects them as obstacle geometry. There's one other area that we need to create an obstacle for the frame, and that's going to be around the front section of the stem. But I'm not going to include this in part of the course, so feel free to try to create it on your own, or we can pick up in the next design in the next video. But make sure that you do save your work before moving on.